We're starting a new mini unit today. Um, this unit is called factoring, and just like we did a lot of simplifying with polynomials in the last packet, this is doing that work backwards. So let's just get right into it. The word factor has two meanings. One thing is to break something apart into two or more things that multiply. Kind of like if you have if you have an 8, factors are 4 and 2, because 4 times 2 is 8. Also, factors of 8 can be 1 and 8. Anything that multiplies to give you that number are factors. And then the second part, this is the backwards process of simplifying polynomials. So today we're going to be working with a type of factoring called finding the greatest common factor. So that means the biggest number, the greatest number that multiplies. And common means it has to be in matching in everything. So there's two different ways to do this. Well, two different ways that I'm going to show you. And your job is to find the way that works the best for you. We have two different problems, part A and part B. I'm going to do this in two different ways so you can see, which one might stick in your head the best way. So part A says given 6x squared and 15 plus 15x, determine their greatest common factor. So I'm going to use this way with factor trees. So the first one I'm going to write down my terms, 6x squared and 15x. I'm going to write it over here. I'm going to give myself a little bit of room. So 6x squared. The way we make factor trees, it's more like scrap work. I'm not going to grade you based on how your factor tree looks. What you're doing is just breaking this thing down to try to find out what all the things are that go into it, all the things that multiply to get 6x squared. So I put 2 and 3 because 2 times 3 is 6. Now I'm circling these numbers because they're prime numbers. If they're not prime, we have to keep breaking it down. So I have 2 and 3, and then over here I have x squared, which is really 2x's, x times x. Okay. Now I've got my 15 over here. So I know it's 3 times 5. And I haven't it's an x to the 1, so it's just 1x. To find my GCF now, I have to find out what matches in both. So I can pull a 3 out and an x out. So I would say my GCF is 3x because the 3 and the x match in both factor trees. That's one way to find your GCF. The other way, and I'm just going to rewrite this problem, 12x to the 4 minus 27. I just want to make it a little bit bigger. The other way you could use, it's quicker, but it's more tricky, a lot more work in your head. Find two numbers, because we have two, or reversed. We have to find a number, the biggest number that divides into 12 and 27. So you have to be pretty quick at your multiplication facts in your head. Let's see. I know 3 goes into both of them. So what I'm going to do is divide these by 3. Your biggest number and your smallest exponent. So I have a 4, I have a 2. So my GCF here is 3x squared. This is the way I'm going to work with the most on videos, but you always have the option to do factor trees. So what I'm going to do now is put up my key so you can copy down the steps. I'm going to try to put up my key. Okay, so pause this video, copy down these steps. This way is the factor tree, and this is the shorter version. Okay. So like I said, pause this and then restart it. We're going to practice finding the GCF next. So for exercise number 2, we are going to practice finding the GCF. And for this purpose, I am going to use the shortcut way. Of course, in class, if you would like to see the other way, that's fine. I'm hoping to zoom in. Oh, good. Okay, I can't lose my pen. So what I like to do, and this is just a preference, I always put little divide by symbols because that's how I think about this. And before I get started, I'm going to put my invisible exponents there as well. So for the shortcut way, we have to find a number, the biggest number that goes into 12 and 18. So I know 2 goes into both. 4 does not. 6. So 6 is my biggest number. And my smallest exponent is right here, x. So the GCF is 6x. Let's look at letter B, and then you are going to try the rest. If I can actually scroll over, there we go. So we have 5x to the 4 and 25x squared. So biggest number that goes into 5 and 25 is 5. Whoops. So GCF, we got a 5, and we have an x to the 4 and an x squared. Smallest exponent is x squared. That is our GCF. Now, again, pause the video. Try C, D, E, and F. And then I will show you my key and work through some of these problems. Okay, letter C. I have 21x squared y to the 5th and 14xy to the 7th. So when I did this, I looked at my numbers, 21 and 14. The biggest number that goes into both of them is a 7. And now in this problem, you have 2 letters, an x squared and y. For now, I'm just going to look at the x's. So I have an x squared and an x to the 1. So my smallest exponent that I take out is an x to the 1. Then I move over to my y's. The smallest exponent is y to the 5th. So that's how I got that GCF. So moving on down to the bottom row, there are 3 terms, and that's okay. You do the same exact thing. So my GCF for letter D is 8x. Now for letter E, again, same thing. In this problem, there's a minus sign. Don't worry about minus signs. When we're factoring, they're there sometimes, but just don't worry about them for now. They're not as big of a player as like when we're solving equations and things like that. And there's my last one. My biggest number that goes into all 3 of those is 9, and I took out an x to the 1 and a y to the 1 in both. So I'm going to pause my video now, and next we'll move on to page 2. We've worked on finding the GCF. On the next page, we're going to work on actually factoring the entire problem.